In the last part of this module, I want to briefly introduce another example. In this case, our data is coming from a study on women, and our main outcome of interest is going to be a binary variable, just indicating whether or not a woman is currently going through menopause or not. And the main predictors that we're going to use are one, age, and that's going to be a continuous variable, and then we're going to use a categorical variable or a dummy for higher education. So 0 is going to equal lower education, and 1 is going to mean some form of higher education, either college or some sort of advanced degree. Here, we're just plotting our outcome based on our two covariates of age and education. From this, even though we're using a jitter plot, so we're separating observations out based on their y values, again, because you can only have a 0 or a 1. You can only be currently going through menopause or not. So we've jittered the y-axis here so that you can see a little bit of variation. Again, it's really hard to discern any pattern here, but clearly women under the age of 55 are much less likely to experience menopause in general. Now let's run our actual logit regression. Here, again, our outcome menopause, our two indicator variables. Here we're using an additive model. This is not an interaction. And here we're specifying the family as a logit link. Looking at our two estimated coefficients here, our beta 1 and our beta 2. First, looking at age, we see that there is a positive and statistically reliable relationship between age and menopause, which is pretty clear, right? The older a woman gets, the more likely she is to experience menopause. The same cannot be said, though, for the estimated coefficient for higher ed. So in this case, when we go from lower to higher ed, we actually increase the likelihood of menopause. We can look at this a little bit more concretely. So again, for a woman in a given higher education level, again, holding higher ed constant, increasing age by 1 year is going to be associated with increasing the odds of having menopause by a factor of about 1.32, so about a 32% increase. And again, we get that by exponentiating that estimated coefficient. Now, again, age is a significant and positive predictor of menopause. So, for a woman in a given age group, we can also look at the effect of higher education. Now, holding age constant, going from less to more education, is actually associated with a decrease in a probability of entering menopause. So specifically in a given group, the odds of a woman with higher ed having entered menopause is 0.49 times less than the odds of a woman with lower education having entered menopause. And we can look at this relationship by fitting the estimated or predicted values along the logistic curve. So here we've done that for both women of higher and lower education for varying levels of age. And what we can see is that in general, women that have lower education levels have higher propensity of being in menopause. Finally, since again, we are doing an additive model here, we are not doing an interaction. In terms of interpreting these parameters, a unit change is supposed to have the same effect on all different groups. In this case, either having low education or high education. The fitted curves should not be then on top of each other because one is shifted to the right of the other. It's there because of higher ed. The predicted probability then of a woman entering into menopause at a given age is different between the two groups. but the slope is explicitly not. However, that would not be the case, so the slopes could potentially be different if there was an interaction, right? So they could potentially cross over. But again, like with any other type of regression models, there's going to be a variety of different forms of the interaction, and so the shape of the fitted curves is going to depend on the estimated relationship. So to wrap up, in this module, we went over how to diagnose the assumptions of the logit regression model, as well as how to best determine model fit.